So EarthSense is an agricultural robotics company, as Jeremy mentioned. And I've worked at this company for 6 years, ever since my college days. I started as an intern and then continued for full time upon graduation. Started out primarily working with what was our TerraSentia robot, which was a robot that was designed for phenotyping in corn and soy. And my primary task at the beginning was count soybeans. Get the robot to, there was a camera pointed at soybeans and it was able to detect the soybeans and count them. Oil palm is, of course, an industry producing a product that much of the world's agriculture and industry relies upon. The core of how our autonomy functions is that we can heavily utilize the fact that the fields are highly structured. So in oil palm, it's similar to the other settings we deployed as well, corn and solar panels, looking into vineyards and stuff, in that they tend to have relatively straightforward rows, predictable row widths, and then predictable lane turns at the end. And so the idea is what you want is a system that is capable of starting at one corner of the field, navigating down a row in the middle of the row without crashing into anything, and then stopping at the end, turning the lane, and then coming back down the next row. And if you can just do that on repeat, those are effectively the two operations that you need to deploy to any large number of acres, basically. When we're going down the row, the chief algorithm that we rely on is the lane detection, as you're describing. I think Renaissance painters centuries ago figured out that a key way to make paintings look realistic was to have vanishing lines. So if you're looking down a tunnel, for example, the lines, the pillars, they all converge to one vanishing point. And so we leverage that geometry to tell us two pieces of information, one of which is how far are we from the center, and another of which is how far are we tilted from the center. And so once you have that information, you can then tell your robot exactly where in the row it needs to travel to relative to where it currently is now. So we have a neural network finding those vanishing lines and generating that target location for us as we go. And from there, it gets passed on to the high level controller, which will figure out exactly how the motors need to turn to get itself centered. And the segmentation model provides another backup signal for that, just in case like a leaf or a frond, let's say, blocks the camera and it can't see, and it might get confused about the vanishing point. The tree detections and the traversable path detection will help provide another signal as a backup effectively. It's also very crucial for the safety side of things, where if there's a person in the field or if there's a tree that's fallen over or if there's a ditch that's not traversable or a puddle that's too deep, depending on how we want to configure those, we'll have the robot detect that it needs to have an emergency stop, and then it will make sure to stop, and then the teleoperator will be able to have it resume.